Hello everyone, welcome back. In this video, we are going to start a topic talking about new function, rational function. In this lesson, we are going to introduce the domain and range, and we are going to analyze this information from the graph of rational function. So before we discuss the domain and range, let's quickly discuss what is a rational function. Why do we call this and how does it look like? Rational function, the first thing you might want to ask is, do you remember this word, rational number? Rational number, as we mentioned before, is kind of fraction. So for example, we can put 1/3, 4/5, or 0.5. All this kind of thing is called rational number. And you can see, no matter it's decimal or fraction, we can always convert it to fraction. So we're going to carry over this fraction feature here, put it into the function. So rational function is the function where the variable is in denominator like that. So the first one, as you can see, this is y equal 1/x. This can be a rational function. Another one I can give you an example is like this. And also I can just change the format as this. So all this example here can be example for rational function. Of course, I can make it more complicated for the denominator, put more layers to the variables, but this is all same. We can generalize this as a rational function. So how the rational function look like? So if we just, this is actually the graph of 1 equal over x. So for this one, as you can see, this graph has two pieces and two curves, and both curves will go two directions forever. There's no like a stopping point or starting point like radical equation we learned in the past. And so as you can see, since we have two pieces, it seems that the graph is not like the one we saw in the past. Like sometimes we see this, or sometimes we see line like this. It's like there's no broken part, but this graph does have, because it's two pieces, it's not connected to each other. So today we're going to use a little bit different technique to analyze the domain and range. Let's see how do we do that. But before that, just another quick review for domain, all possible values of x, which is domain. And the range is all the possible values of y, which is another word. We can use input for x, output for y to interpret the domain or range. Okay, let's check how do we do that. So as you can see here, since we have two pieces here, and since there is a breaking part, like there's a missing part, there's a broken point where the graph is not connected to. So our job is to focus on to analyze where is that broken location. So one thing is, even these two curves are separated in the two quadrants here, but imagine if I just extended this part, go up forever, and if I extended this part, go forever, and you will notice that this function will getting closer and closer to this line, right? And horizontally, if I just connect it to this one, or not really connect, I extended both parts in the two directions, and this one will connect it to this two. They're getting very, very close. And the most important part is the word we use in approaching is not really intercepting. So you wouldn't imagine the graph actually touch this, no. But instead, it's like getting closer, closer to this. And in the next lesson, you will see we do have a name for this kind of line. But today, since, okay, so we do have two lines here, and where do they intersect? They intersect 0 and 0. So this location is actually exactly location for the graph does not have definition. What does that mean? You do not see the graph actually passing through this point, and this is a location where the graph actually not connected to. So that's why for the domain is talking about the x, and since x is not at this point, you don't see any point actually linked to x due to 0, then that means x can be any number but 0. So we can, this sign here is called not equal to, meaning the domain x can be any number. You see any definition for the left side, for the right side, but you do not see any definition for that. So that's what do we call this? X cannot be 0. For y, same thing. you can see anything like up and down. Everything is demonstrated on the graph, but not zero. So that's why we put this one. This symbol is called not zero. Sometimes you will see this. We say x belong to real number, and this R here meaning real number system, but x is not zero. That means x can be any number you see on the number line, but not zero. Okay, that's what will happen here. And oh, by the way, another way to demonstrate this is like all numbers. This is we demonstrate like using another notation to demonstrate the domain or range. This one because x is not belong to zero, so zero exactly the broken here. Okay, so that's one thing here. But of course, you can just use this notation to demonstrate what is a domain or what is a range. But I just want to show you, probably sometimes you will see the different notation like that, but they are equivalent. Let's check another example. Like we used in the past, the first thing we are going to, I'm going to change my pen a little bit thicker so it's easy for you to see the line. So this is where the graph approaching to, again, if you imagine both sides of this, as the extended it closing to this one. So vertically check. For this piece and this piece, they're actually getting close to this line, right? So we are drawing two lines where they close to, and the point they intersect at this point, which is 1, 0. So now let's write down their domain and range. Again, set notation indicates this is about x, and x is broken at the 1, so it's not equal to 1, and the range is for y, and y cannot be 0. That's how do we do this. Let's check one more example and we can summarize this lesson. Again, the first thing we always wanted to draw the two lines where the graph approaches to. Vertically, as you can see, if I extended both sides here, they actually getting close to this line. And vertically and horizontally, they're getting close to this one. Again, you are welcome to pause the video to check these lines by yourself, like where do you see this? Where do they approach to? Next, let's write down the final answer, which is, again, we use this notation to demonstrate domain, and x cannot be the coordinates for this one is -4. Do not forget, we always read x, -1, -2, -3, -4, then go down -2. So that's why the location for this one is -4, -2. And for x is now -4, and for y has no definition at -2. So again, this is a location. The graph has no definition. You do not see the graph passing through this point, and that's why we demonstrate x can be any number on the number line, but not -4, same as y. Okay, thank you so much for watching this video and study this topic with me. See you soon, everyone. Take care.